Hey guys, this is test 33 game 3. This is the Jeweler and Stones game. It's an in-out game, also known as selection. And like many of these in-out selection games, we've got lots of conditional statements, some of which link together. In this particular game, they are not all linking together. The other unique thing about this game is that we've got a bunch of categories of variables. They are not all just general variables. We've got, you see here, rubies, sapphires, and topazes. We've got to deal with that element of the game, as well as all the other conditional stuff we normally have to deal with. So this slightly increases the game's difficulty. Anyway, the first rule, at least 2 topazes are selected. We've got 4 of them right here, W, X, Y, Z. So we are now learning that it's 2 and up. We don't actually know the total possible number of topazes. Next, if we've got 2 sapphires, then we have got 1 ruby. And because this game is a selection game and they tell us specifically there are 6 in from a total of 10, we can make a little in-out table and put 6 above the in and 4 above the out. So now that we learned 2s requires 1r, 2s is thereby requiring 3t as well, since we would need to have 3 more exactly. We need to have exactly 3 more stones to make our total of 6. Next, if we have W, then we lack both H and Z. So W in requires H out and requires Z out. Contrapositive, if either H or Z is in, then we will have W out. Next, M in requires W in. Contrapositive, not W requires not M. Now we can make one additional inference here. We see that W in requires Z out and Z in requires W out. They are both within the topaz category. So we cannot actually have all 4 of them. It's really a range of 2 to 3. Whereas for the other guys, it's really anywhere from 0 to 3, completely open-ended there. Now for number 13, this is a typical orientation question. We would just want to take one rule at a time and apply that rule to all 5 choices looking for violations. So we can start by looking for choices that mention M, because M in requires a lot of other things. M in requires W in, H out, and Z out. So any choice mentioning M must have W and then lack both H and Z. So A mentions M, yet does not contain W, so A is gone for number 13. B mentions M, also mentions W, so we're good there. It lacks both H and Z, looking good so far. We'll skip it for now. C does not mention M, so we'll skip it. Neither does D nor E, so we'll skip those for now. Now that we've exhausted the usefulness of M, we should move on to W. W in requires H out and Z out. B mentions W, does not mention H and Z, so we're good there. C mentions W, lacks both H and Z. D doesn't mention W, but E mentions W, yet has both H and Z. Unacceptable. E is gone. Now we can look forward and say to ourselves, okay, we've exhausted the usefulness of this. What about the 2s thing? So 2s requires 1r and 3t. B has 3 s's, not exactly 2, so we'll skip that. C mentions exactly 2 s's, J and K, yet mentions 2 r's, F and G, not exactly 1. So C is bad on this issue and eliminated. D mentions only 1 sapphire, so we'll leave that alone for now. Now, we can also make use of the fact that we have to have at least 2 topazes here, at least 2 first rule of the game. We see that B mentions only 1 topaz. It mentions W only. We need to have at least 2. So B is unacceptable, and D is our answer by process of elimination. You will want to solve these questions typically by process of elimination. Next, number 14, what must be true in general? We saw from number 13 that we had a valid scenario there, so that could potentially help us for number 14. However, basically what I mean is that any choice for 14 that did not occur in 13D, as in delta, our correct answer there, is not a must. However, if we look back at 13D, we'll see that every answer choice from 14 occurred there. We had all of GJX in 13D. We had exactly 1 stone from a particular category, and we had exactly 3 stones from a particular category. So 13D will not help us, unfortunately, and we're kind of at a loss for a moment. But then if you think about it, we don't really need to have any of G, J, or X in particular. None of our rules here were referring to those guys or making us think they were special. So we're not going to start with those. Instead, we should start with D and E of 14. Exactly 1 and exactly 3. What are they talking about here? They're talking about distributions. The number of things that you choose from a particular category rather than the specific variables themselves. So I'm going to do a little distribution here. Topazes are the most limited category because we have either 2 or we have 3. So I'm going to use that as my basis here. So if we have 2 topazes, then we have to have R and S collectively add to 4. But there are not 4 rubies and there are not 4 sapphires. So it's not going to be like 4 rubies, 0 topazes, or 0 rubies, 4 rubies, 0 sapphires, or 0 rubies, 4 sapphires. Instead, we're going to have them add together to 4 by doing 3 and 1, or 1 and 3, because those are other ways to add to 4. Now we're not going to do 2 rubies, 2 sapphires, because 2s requires 1r. That would be invalid to say that 2s occurred along with 2r. So we've exhausted the usefulness of 2 topazes, but what about 3? If we had 3 topazes, then R and S have to add to 3. That could be with 3 rubies, 0 sapphires, or it could be 0 rubies and 3 sapphires, or it could be 1 ruby, 2 sapphires, 3 topazes, or 2 rubies, 1 sapphire, 3 topazes. Those are all different ways we could add to 6 altogether. These are all the possible distributions for the game. So now if you look at them, you'll see that every single scenario right here, all of them had exactly 3 of something. So choice E is our answer for 14, whereas we did not always have exactly 1 of something because we have 303 or 033. That does not contain exactly 1 of any specific category, so E is our answer for 14. Next, number 15. If Z is selected, what could be true? So we can make a little in-out table here, or I'll actually use the one I drew up on the top left here. If Z is in, we know that W is out and M is out. That's all that really logically follows from this specifically, so we'll use that to help us out here. What could be true? Could we ever have all 3 sapphires? Well, M is, as you see, a sapphire. So no, we could not have all 3 because M is out and A is eliminated, as are B and C because they are both listing M. Could we have 0 rubies as D suggests? No, because 0 rubies, as you see down here, 0 rubies requires 3 sapphires. And again, M is a sapphire and M is in the out column, so D is gone, and E is our answer by process of elimination. As you see, 0 sapphires is entirely possible. We could have 3 rubies, 0 sapphires, 3 topazes, no problem, that works fine. So E is our answer for number 15. Next, number 16, if exactly 2 rubies are selected, what must be true? Well, we see here from our distribution on the bottom that exactly 2 rubies requires 1 sapphire and 3 topazes. Choice D of 16 says 1 sapphire, so D is our answer to number 16. Number 17, what must be true? General question, just look at the information that we have in general. At least 1 ruby? No, we could easily have 0 rubies, as you see from the distribution at the bottom. A is eliminated. At most 2 rubies? No, there are actually 2 different distributions. The first one I listed and the third one I listed, where you have even more than 2 rubies, you have 3 rubies. So B is eliminated. Now it gets a little bit tricky to navigate C, D, and E, but our knowledge of the limitations of the topaz category at the top left here can help us out. Because we know that W and Z conflict, we're never going to have both of them. At least one of those 2 is always out. So if you want to have 2 topazes, what might those be? Well, you've always got to have at least one of X or Y. At least one of X or Y, and then the other one of those 2 could be the other one of X or Y, or it could be one of W or Z. So we could have one of XY, one of WZ, or we could have one of XY, and then, well, the other of XY. So what I really mean there is we could have both X and Y, or just one of xy, one of wz. Those are the only ways we could reach our minimum of 2 topazes. We couldn't have both w and z. That would be impossible because they conflict. So what I'm really driving here is that D is our answer for number 17, at least one of x or y at all times because of the WZ conflict. Next, number 18, if J and M are the only sapphires selected. So J and M are both in the in column that I'm using on the top left here. J and M are in, and they are the only sapphires, meaning that K, the remaining sapphire, would have to be out. Now, we know that M requires certain things, right? M in requires W in, H out, Z out. So since we know M has to be in, we can use that information. W is in, H is out, Z is out. Now there are only 4 things in the out column here, right? We already have 3 out, so only one more thing out remains. It turns out that J and M being the only sapphires activates the 2 sapphire rule right here. 2S requires 1R requires 3T. We can only have 1 ruby in. Our rubies are F, G, and H. H is already out. So our remaining single ruby will have to be one of F or G. The other one of those guys will have to be out, G/F, because we cannot have both of these rubies due to the activation of the 2S rule by J and M. So now that our out column is full, our remaining variables, x and y, will have to go in. They're going in the in column. So as you see here, we have f and x as a possibility, which is what choice B for number 18 is indicating is possible. That could be true, that we have both f and x in, and B is our answer for number 18.